Welcome to our notes on the unit vector and linear combinations of vectors. Students will be able to write a vector as a linear combination, calculate the directional angle of a vector applying right triangle trig, and find the unit vector. A unit vector is a vector with a magnitude of 1. We can find the unit vector by dividing vector u by its magnitude. We then denote the unit vector as such, which is pronounced u hat. As an equation, we would say that u hat equals the vector u divided by the magnitude of u. And the magnitude of u is a number, so it's like scalar multiplication. If you think about this. So 1 over the magnitude is just a number. So if you multiply it by the vector like we've seen before, you can find the unit vector u hat. So recall that the component form or standard form of a vector is as follows. The scalars v1 and v2 are called the horizontal and vertical components of v respectively and can be written as what is called a linear combination of vectors I and j. Vector I is the horizontal unit vector, so it looks like this. Remember, a unit vector has a magnitude of 1. And vector j is the vertical unit vector, so it looks like this, with a magnitude of 1. The hat can be omitted here, so usually we would have written it as I hat. We can just write it as I, or j hat, and we can just write it as j. Sometimes you'll see the hats in textbooks. So here's the linear combination form of vector v. It is the horizontal component times I plus the vertical component times j. You can solve vector operation problems by converting u and v from linear combination forms to the component form, but it's not necessary. You can perform the rules you learned in the previous notes to vectors in linear combination form as well. For example, let vector u equal negative 3i plus 8j in linear combination form is equivalent to vector u in this notation in component form. We actually didn't need that word let, so so I just crossed it off. Now, it says name the 3 ways vectors can be represented. So you'll use your notes now as well as previous notes to answer this question. So now what we're going to do is we are going to figure out the component form formula if we were given a magnitude and a directional angle. So in the diagram column, it says label the x, which is the horizontal component, the y, the vertical component, the magnitude of the vector, and theta on the diagram below. So if I were to drop a perpendicular, this seems all too familiar, right? We just studied a lot of right triangle trigonometry. This will be my y, this will be my x, and this will be my theta. Well, remember, the magnitude is the length of the vector, so that means this right here is the magnitude. The next column is the geometric representation. Mark up the following text and answer the questions below. Direction is measured in different ways and in different contexts, especially navigation. A precise way to specify the direction of a vector is the directional angle, the angle theta that the vector v makes with the positive x-axis. Using trigonometry, how can you find the horizontal component of a vector given theta and its magnitude? So if all I had was theta and its magnitude, I need to somehow use trigonometry to relate this and this. I'm going to delete that highlight in a moment. So what's the relationship between those two using theta? Well, this happens to be cosine. So cosine of theta equals x over the magnitude of v. And then if you solve for x, then that means it's the magnitude of the vector times cosine of theta. Number 2 says, using trigonometry, how can you find the vertical component of a vector given theta and its magnitude? Well, very similarly, the sine of theta is y over the magnitude. So y is the magnitude times sine of theta. Number 3, using questions number 1 and 2, write a formula that you can use to find the component form of a vector given the directional angle and the magnitude. So the x is just going to be the magnitude times cosine of theta, and the y is going to be the magnitude times sine of theta. Alright, so let's use 3 decimal places here. When plugged into the calculator, the x component is going to be negative 2.536, and the y component, or the vertical component, would be 5.438. Now to write this in linear combination form, I'm just going to write negative 2.536i plus 5.438j. Alright, so now let's find the unit vector v hat. V hat is going to be our vector divided by the magnitude of that vector. So if I just find v hat, the magnitude is 6. So 1 over 6 times vector v. Just think scalar multiplication. I'm going to go ahead and just put this in my calculator. I just did the negative 2.536 and divided it by 6. And I'm going to get negative 0.423 if I go to 3 decimal places. And then I took the 5.438 and I divided it by 6 to get the 0.906. So there's my unit vector. So why don't you try practice 2? Discovering how to find the direction for a vector. So if you didn't have theta, how would you find it?